All right, next up, we're going to be reviewing electromagnetic spectrum, light, and sound. So first off, our different wave properties. So first we have wavelength. So wavelength is just how long the wave is. So it can be measured either from the top of one wave to the top of the next wave, or from the bottom of one wave to the bottom of the next wave. You see, either way, you get a full wave in there. So wavelength is how long a wave is. So shorter wavelength here, it's going to look like they're smushed together. And a longer wavelength is going to look like they've been pulled apart. So that's wavelength. All right, next up we have frequency. So frequency is how many waves pass by a point in a given amount of time, normally a second. So if I were to stand in one place and count how many waves pass me every second, I'd be measuring frequency. Or let's say I stood on the beach and count how many waves hit the shore over a given period of time. I'd be measuring frequency. All right, so frequency and wavelength are related. So remember, this is our semi and motorcycle example. So our longer wavelengths are going to have lower frequencies, and our shorter wavelengths are going to have higher frequencies. So if we hit play and these waves started moving at the same speed past this point, it would take a lot longer for these bigger waves to pass by that point. So we'd have a lower frequency. Whereas these short waves, they would pass by the point really, really quickly. So they'd have a high frequency. So if we are standing on the side of the road and we had a line of semi-trucks and a line of motorcycles driving the exact same speed past you, and it counted how many of those pass you every minute, you'd have a lot more motorcycles passing by you because they're shorter. There's less of them to get by you. We'd have a lot less semi-trucks because they're longer. There's just more of it to get by you. So smaller wavelength equals higher frequency. Longer wavelength equals lower frequency. All right, so the only electromagnetic wave that we can see is light. So our visible light right in the middle of the spectrum is the only one that we can see. And our visible light spectrum is split up into our different colors. So the reason we see different colors is because the different colors have different wavelengths and frequencies. So if you see here, that red side of the visible light spectrum is closest to the radio wave side of the spectrum. So red waves are going to have the longest wavelengths, the lowest frequency, and the lowest energy. Purple on the other end of the spectrum is going to have the shortest wavelength, the highest frequency, and the highest energy. So when it comes to seeing color, the color that we see is the color being reflected by the object. All other colors are being absorbed. So for example, I have a green straw right here. So this green straw, what's happening is the white light is coming down and hitting it. And remember, white light is made of all of the different colors. This straw is absorbing every color except for green. It's reflecting green. That's what reaches my eyes. So that's what I see. So the color you see is what's being reflected. So white and black are a little bit different. So white is going to reflect all the light that hits it. Remember, white light is made of all different colors of light. So if all colors are reflected off of a surface and all colors reach our eyes, we see that as white. So if I have a white piece of paper, what's happening is the white light is coming down, hitting it, all bouncing off into my eyes, so I see white. Black is going to absorb everything that hits it. So you can remember that by thinking about your t-shirts in the sun. So a white t-shirt is going to stay a lot cooler than a black t-shirt. That's because that black is going to be absorbing all of the sunlight that hits it. And that white is going to be reflecting all the sunlight that hits it. And light's going to travel fastest in a vacuum. Remember, a vacuum is just an absence of anything. It's empty space. And slowest in solids. So light travels fastest, and all electromagnetic waves travel fastest when there's nothing to get in its way in a vacuum. It's going to slow down a little bit in a gas, a little bit more in a liquid, and even more in a solid. And light behavior. There are three things that can happen when light hits something. So one, it can refract. So refraction is when the light goes through whatever it's going into. Like let's say it's going from air into glass. So that light's going to